This is a video on the subject of a theory of everything. And if we're going to talk about everything, then we've got to start with nothing so we can cover the whole ground. So what is nothing? Well, nothing is the absence of anything. It is absence, it is not a quantity. And since we're talking about quantities, we should perhaps clear up what zero is, because zero is also associated with nothing. But we can illustrate a little better, I think, the difference between nothing and zero, and the difference between nothing and the absence of anything. Let's start with a simple mathematical trick. Stop me if I make a mistake. 2 minus 2 is equal to 1 minus 1. Is that all right? Let's factorize this. 2 into 1 minus 1, that's taking the 2 out of there, is equal to, and we'll do the same thing here, 1 into 1 minus 1. Now let's divide both sides by the same quantity, and we get that 2 is equal to 1. And obviously you must have stopped me by now, because that's clearly not correct. Now why is it not correct? One thing I learned at school is that you should not divide by 0, and I have divided by 0, but really, you know, if this were an algebraic equation, a minus b and a minus b in here, you could divide by a minus b with no problem, and you would not perhaps consider that a could be equal to b, and therefore you're dividing by 0. It's not the problem that you divide by 0, but you're dividing by 2, in this case by the same 0, but you can, if this were divide both sides by 2 minus 2 and 1 minus 1, you could see that they were different. The point is that 2 minus 2 is not equal to 1 minus 1. It is twice as much. And this is an interesting subject. If you define 0, which 0 you mean, and you say let 0 equal 1 minus 1, then you can't say that 2 minus 2 is equal to 1 minus 1. That would be 2 times 0 is equal to 0, which was obviously, or not obviously incorrect, but it is correct, as we saw, incorrect, as you saw before. So if 0 is the 0 amount of something, and those things, or whatever it is that is something, has to be the same in both cases, including the quantity. Well, the same thing applies to nothing. Having no apples is not the same as having no oranges. So what is an absolute nothing? Well, you could say it's an infinite amount of empty space. But empty space is one of the most important features of the physical universe. Potential energy is associated with the amount of empty space in between two bodies. Now I know some will say you require an energy field, but I'm going to show, I think, that you don't require an energy field. There's energy there, but it doesn't have to consist of anything. It is the fact that bodies are separated. And that, of course, brings up the subject of gravity, which is a later subject. But let's see what nothing can be described as. Well, it has no size, because it's nothing. It has no shape. You could describe it as a dot, but even a dot has some size and some shape. So I'm simply going to say, I'll draw a circle, and in there somewhere is some nothing. In other words, there's nothing in there. But I can denote where I'm talking about by the circle. And supposing that we had, we were to draw now a network of what a very, very fundamental universe could look like, made out of nothing. Let's draw it first and then see how it could be made out of nothing. The basic structure in our universe, whether it's a galaxy or a solar system, a planetary system, whether it's a compound, an atom, or whatever it is, it consists of mass separated by mass in various ways. So I'm going to draw a network here of points that are separated, and we can say they're separated by space for the moment. This is a network in which there's also one here, but I'll draw a curved line around it. Every unit of matter or body of matter connected by a separation. And this is true of a solar system. I mean, this could be the Sun, the Earth, Mars, Venus, Jupiter, and so on. They are all connected by the fact that they are separated in space. But if we take it down to the smallest possible size, because you see we have, in taking a solar system, you've got to explain what the Earth is and what the Sun is. Let's go down to the smallest possible size where the same basic structure exists. One single unit of matter, another single unit of matter, separated by space. Another one here, another one here, and so on. Now you'll notice I've only drawn 4 units of matter, and that's because I've drawn this on a 2-dimensional board. If I try to add another one, that's going to have separation between it and all the other bodies. And if you have only 2 dimensions, that's going to cause a problem, because the space between 2 bodies is important in physics because it represents the potential energy. And if, for example, when the Earth gets between the Sun and the Moon, or the Moon gets between the Sun and the Earth, then we have an eclipse, and that creates problems. It doesn't create problems with gravity for reasons that we'll have to wait, but it does interfere with light. And so if you're going to have 4 bodies, you can have them on a 2-dimensional system. If you have 1-dimensional system, you can only have 2 bodies, because a third either interferes with the relationship between the first 2. If you put it outside, then it cannot have a relationship with one that's the other side of the body. So one-dimensional system can only have 2 bodies in it. A 2-dimensional system can only have 4 bodies in it. So we need more dimensions, and that's the reason why we have 3 dimensions of space. So I can now draw as many bodies as I want, and if they're in 3 dimensions, then these can be at different heights, and therefore you can have connections between every one. And so on. Because those interferences are straight lines that can get through a 3-dimensional system. Now it's important to remember that these lines have no width, they are simply separations in space. There's no volume to that, it's just a length, nothing but a length. And in these fundamental units of matter have no size. So that there's no limit to the number of dots I could draw here if I could draw lines of no width and put in dots of no size, and I had a 3-dimensional system to put it into, then I could have as many as I want, and that's why we only need 3 dimensions in the universe, because the billions and billions of stars and planets and moons can all have a separation, a relationship, a line of force is a good word, between them in 3 dimensions. You don't need more. So that is how, now you'll notice everything there actually boils down to nothing. The units of matter are just junctions between separations. There's no need to have any size or shape to that object there. It's just the point where two separations meet, and the separations themselves have no cross-sectional area, and therefore they have no volume. If they have no volume, we can say that they are simply separations and nothing more. So you could construct an enormous universe made out of nothing. And that's the subject of an essay I've written on the subject of a theory of nothing. And I think we have, that must be the explanation, or associated with the explanation, that explains how the universe could have been made out of nothing. Later we'll see how we can get mass and apparent size and volume and things. But right now we're dealing with nothing.